Okay, so in a different video I talked about atomic structure, and we talked about protons, neutrons, and electrons, and now that we understand what an atom is made up of, we can understand what isotopes are. An isotope is just they're atoms that have identical atomic numbers, but they have different mass numbers, and they have different mass numbers because the number of neutrons is different. So let's use carbon as our example, and let's do carbon 12 and carbon 14. Maybe you've heard of those before, carbon 12 and carbon 14. And what makes these different is the number of neutrons. So if you look at your periodic table, you'll see that carbon has, well, let me show you. It looks like this. Okay, so this is its atomic number, and this is its mass number. So it has an atomic number of 6 and a mass number of 12. So that atomic number is telling us it's the number of protons. So there's 6 protons, and it's the number of electrons as long as the atom is neutral, and in this case it is. So it's 6 protons and 6 electrons in this case. To find out our number of neutrons, we take our mass number and we subtract our number of protons from it. So 12 minus 6 is 6. So we have 6 protons, we have 6 electrons, and we have 6 neutrons. If you're ever wondering why you subtract the 6 from this, if you think about it, we're talking about protons and neutrons, but we're not considering electrons in here. That always confuses first-year chem students, or not all first-year chem students, but it confuses a lot of students. And if you watched the video before this, I did mention it. The reason for that is because electrons are so small that their mass isn't even considered. So that's why we don't. It's so small we just don't include it. So we only include the mass of the protons and the neutrons. So that's why, in case you're ever wondering. Anyway, okay. So 6 protons, 6 electrons, and 6 neutrons, and that is typically what carbon looks like. But now there are isotopes of carbon. So what we have right here is carbon 12, and I can prove that to you because carbon 12 is its mass number. Okay, carbon 14 is its mass number. So carbon 12 has a mass number of 12, like I said. So that means that it has together 12 protons and 12 neutrons. Well, we know that by looking at our periodic table that carbon has 6 protons. So to find out our number of neutrons, we'll just subtract it. So we know we have 6. And look at that. So we have 6 protons, we have 6 neutrons, and then of course we know we have 6 electrons. And we know we have 6 neutrons here, and we can go look at that. And like I said, so that's carbon 12 that we're looking at. This right here is carbon 12. And now carbon 14. What's different with carbon 14? Well, let's find out. Again, we know we have an atomic mass of 14. We know that we have 6 protons. So we're going to subtract that. Remember, like I said, our electrons don't matter here. We don't need to consider those. We're just talking about our protons. We need to figure out how many neutrons are here. So 14 minus 6 is 8. So 8 neutrons. And that is our difference. We have 2 more neutrons in carbon 14 than we do in carbon 12. And these are what, the number of neutrons is what makes isotopes of carbon. I mean, the number of neutrons is what makes isotopes of anything. That's what makes them different. So if we looked at carbon 12 versus carbon 14 would just have 2 extra neutrons in its nucleus. That would be the only difference. What else can I tell you? If we were looking at hydrogen, for example, if you look at hydrogen on your periodic table, it has an atomic mass of 1.01. let's see if I can remember this. Hydrogen has three isotopes that occur naturally, and I know that one of them is found much more frequently, or much more, well, I guess frequently is an okay word to use there. It's found more often than the other ones, and so if we took samples, okay, there. Let me tell you what they are. We have protium, which has zero neutrons, and then there's deuterium, which has one neutron, and then there's tritium, which has two neutrons. Okay, and of this isotope, there's mainly these that are occurring on the Earth that we find. Okay, in any given sample of hydrogen. In any given sample of hydrogen, we might find a few of these, and we might find a couple of these. And what we do, and maybe I'll make a video and we can do an example on this, but what we do when we find these, we'll find a percentage of each, and then we take those percentages and we add them up, and we do what's called a weighted average mass. And you've probably done weighted averages before in math class, but we do a weighted average, and that is how we get that 1.01. So that's where that number comes from, if you're ever wondering how they get those numbers. So maybe that makes a little more sense to you. So kind of a short video. Really not too much on isotopes. They're actually pretty simple. Just takes a little practice working with them. So if you have any questions, just shoot me an email or comment, and I will get back to you.